Okay, in this video we'll look at conditional probabilities. Conditional probabilities are easiest to be understood if you can put them on a table. And there will be a number of example problems that you'll have to do in your homework as well as potentially on an exam. By definition, a conditional probability is a probability of an event given a specific condition or conditional event that occurs. So if E1 and E2 are two events that are independent of one another, then the probability that E2 occurs given E1 has occurred is denoted by the following notation. So the number after the line, E1 is that condition. So, the probability that I have an umbrella given that it's a rainy day. So we would look at the number of, the probability of the event that it's rainy given the probability that I would have an umbrella. Those are two independent events. We calculate these conditional probabilities by taking the probability of the condition and the event divided by the probability of the condition. We'll talk more about this in a little bit more advanced subject in class, but I think I can show this much easier if we just put it onto a table. So suppose that we sample a number of people and we ask them what type of music do you like, classical, country, or rock? And then we also ask them, where do you live? The southeast, southwest, northeast, northwest. The questions that we're asking them here, country music, rock, classical, these are mutually exclusive. If you like classical, you can't like country. At least you can't respond twice. And then the same with the rows here, which is if you live in the southeast, you can't also live in the southwest. However, you could live in the southeast and like classical music. Okay, so there is this independent where you could like, or both events could take place. So what we do is we calculate the margins. So we're going to calculate the total number of people that live in the southeast and the total number of people that like classical music. And we calculate those margins, and that's nothing more than just adding up those values. And then if we sum all of the columns and all of the answers from the rows, we see that they are equal, or at least if our math is correct, they're equal. And there are 1,000 responders to this questionnaire. A marginal probability is the sum sitting in the margin, either the margin to the right or at the bottom. So, a marginal probability that a person in the sample listens to rock music, all we need to do is go to the marginal number that like rock. There are 400 people that like rock, divided by the total number of people that we've surveyed, and the probability is 450 out of 1,000. 0.45, or you could change that by multiplying that by 100%. Percent is a unit, and we would see that 45% of our responders listens to rock. The same with the Northwest. So there's 200 responders in the Northwest and 1,000 total responders, so about 20% or 20% live in the Northwest. That's a marginal probability. A joint probability is that the person it falls into two possible characteristics. So for example, what is the probability a person lives in the Southwest and listens to rock music? Now we're not looking at the margins, we're looking at where the two items cross. So the Southwest and rock, we would go over to the Southwest until we found lives in the Southwest and listens to rock music. Oops, went through the wrong column, I apologize. We find that there are 160 people that live in the Southwest and listen to rock music. So this is a joint probability, meaning that it's the joint of two independent events, divided by the total, which is 1,000. So 16% of my population in the sample listen to rock music and live in the Southwest. Okay? Now conditional probability. This is a little bit tougher to understand, but on a table it's easier to see. So a conditional probability is a probability that an event will occur given that another event has already happened. It's computed by taking the joint probability of both events and dividing it by the marginal probability of the conditional event. So, the conditional probability. What is the probability that a person lives in the Southwest given that you know that she or he likes rock music? So, the rock music is the conditional event. The joint probability is the probability that a person lives in the Southwest and listens to rock music. Hopefully that you can see that by saying that we know the person listens to rock music, it eliminates all of the people that like classical or country. So what happens here in our probability calculation is that the denominator, the total number of possible events that happens, is reduced. It's reduced, in fact, from 1,000 to only 450. So the probability that the joint condition of Southwest and rock divided by the probability of the conditional statement rock, we find that there's actually a 35% chance that that joint conditional statement is true given some conditional statement. Now, it's a common misconception to think that you can switch the conditional statement with the event that you are looking for. So, for example, if I wanted to know the probability that a person lives in the Southwest given that they listen to rock, I find that it's 35.56%, or about a little bit more than a third of the possible subset. However, the probability that a person listens to rock given that they live in the Southwest is different. See, because if the conditional statement is that they live in the Southwest, it eliminates all of the people that don't live in the Southwest. So Northeast, Northwest, Southeast. There are 350 people that live in the Southwest. So the probability that that is true is 45%. Now you'll see in your notes that I have some notes in there about Bayes' theorem. And rather than to discuss this in these videos, I'd rather discuss it in the class. It's more of an advanced topic, but I think it's quite fascinating when we kind of take this idea of conditional probability and conditional probability tables and think about ways in which it affects each of you individually. Also, this is a way that is a method that shows how conditional probability and probability in general is commonly misunderstood by the general population.